So the Kirchhoff's second law, the total EMF in a loop is always equal to total potential difference. So the sum of the EMF, electromotive force, will always be equal to sum of the potential difference in a loop. Now, as we did another example of a single loop, then I do a question for the 2 loops and 3 loops. So we have a 10-volt supply. And we have a 20 ohm resistor and an unknown resistor R is there. And the current in the circuit is 0.1 amperes. And you want to find the unknown resistance R. So how we can work out the unknown resistor R? So we will use the Kirchhoff, like first, only one supply is there. So mean this is the direction of the flow of the charges. So when we apply the Kirchhoff first law, according to Kirchhoff's first law, the total EMF will always be equal to total potential difference in a loop. So what is the total EMF? The total EMF is 10. What about the total potential difference? It's a product because the current is 0.1. So 0.1 ampere will flow through the 20 ohm resistor and the 0.1 ampere will flow through 20 ohm resistors and a 0.1 ampere will flow through resistor R. So what is the potential difference here, which is a product of resistance and voltage? So this will be equal to 20 times 0.1 plus R times 0.1 or 0.1 R. So when we simplify this, so this is 10, 20 multiplied by 0.1, that's 2 plus 0.1 R. So this will be subtracted because 2 move other side, 10 minus 2, 8. So 8 is 0.1 R. So 8 divided by 0.1 is equals to R. So what is the value of R? 8 divided by 0.1. So that is equals to 80 ohms. So R is equals to 80 ohms. So using the Kirchhoff's second law, you can also work out unknown quantity in the circuit, which is in this case was R. So we can work out R as we were having the potential difference as the EMF. Is it clear, this example about the Kirchhoff's second law? Any doubts? Okay. Now, so this was a single loop. Now, what if we have 2 loops? Like a circuit with multiple loops. So in that case, you have to divide the questions into different parts. First, I will draw a circuit like we have a 6-volt supply. And it is connected to a 30 ohm resistor. And and we have a 10 ohm resistor and that is connected to 2-volt supply. And the direction of the current also given, like let's say this is given I1, that is given in the question. And this is I3. This one is I2. This one is also I1. And this one is I2. And the question is using this Kirchhoff's law, calculate the current in each resistor. Like how much current will flow through each resistor, that is what we have to calculate. Okay. Now, what happened to current direction? No, the current direction is given to us. In the question, it is given when we apply the law, how to apply this. The direction of I1, I2, I3 is given to us. And the question is, you have to find the current in each resistor. So when you apply the Kirchhoff's law, you can first and the second law. When we apply the Kirchhoff first law, according to Kirchhoff first law, the total current which enter at any point will always be equals to total current which leave the point. So if I take this point, so what is the total current enter? Means I1 will enter and I2 will enter a point, and how much current will leave the point? So I3 will leave the point. So I can say I1 plus I2 should be equals to I3. That is according to the Kirchhoff first law. When multiple loops are there, you always try to relate the currents with each other, first point, and the second you will take the loops. Now, first thing what we did, we took the Kirchhoff first law at any point when we draw. Even if you mark a point here, you will find that this is I3 and this one going is I1 up and I2 is down. So it means I1, I3 is also equals to I1 plus I2. It's the same equation. So whenever multiple loops you see, you always apply a Kirchhoff first law to relate the current in the circuit with each other. That's the first thing. Now what we do, now we'll apply the Kirchhoff second law. And when we apply the Kirchhoff second law, we have how many loops we can take. As you can see here, like there are multiple possibilities of taking the loop. I can take this as one loop of the circuit. According to Kirchhoff first law, the total current at enter at any point will be equals to total current leave a point. So the current I1 enter and I2 enter. That's why I wrote I1 plus I2, and the current I3 leaves. So it is equals to I3. That is the Kirchhoff's first law. Now we can take multiple loops. For example, if we are taking the upper loop, like if we take this loop. So this is a positive terminal and negative terminal. So what is the direction of the flow? The direction of the flow should be like this. Because positive terminal, always the conventional current move from positive to negative. So this is a direction. So if we only take this loop, so in this loop, when we apply the second law, the Kirchhoff's second law, according to the Kirchhoff's second law, the sum of the EMF in the loop will always be equal to sum of potential difference. So when we take the direction, the total EMF is 6 because there is no other supply. And the total potential difference, because this 30 ohm is there, so it will be equals to 30 is the resistance and the current is I3. So we can say it will be equals to 30 I3. And then the current here is I1 and the resistance is 10. So we can also say 10 I1. Is it clear when I take the upper loop and form this equation? Any doubt? Any question or doubt in this loop? So we took the upper loop and we formed this equation. Now, when we take this loop, the bottom loop, when we take the bottom loop, so this is a bottom loop, like this is positive and negative. So what will the direction of the flow? So the direction of the flow in the bottom loop should be like this, because from positive to negative. So when we take the bottom loop, the total EMF must be equals to total potential difference in the bottom loop. So what is the total EMF? The total EMF in the bottom loop is 2. So we write 2. Because 6 is not in the bottom loop, 6 is in the top loop. Is equals to total potential difference. So what is the total potential difference? The current I3 is going through 30 ohm and there is no other resistor. So I can say this will be equals to 30 I3. Now we have three equations. This is equation A, you can say. This is equation B and this is equation C. You have three equations and you have three variables, like three unknowns. So you can use these three equations to find. Like if we use the third equation, when we start solving, we start with the last equation. So when we use the last equation, so 2 is equals to 30 I3. So 2 divided by 30 is equals to I3. So 2 divided by 30, what's the answer? 2 by 30 or 1 by 15? What's the answer for this? 2 by 30? 0.66, is it 0.066 or 0.067? Okay. So this is 0.067. So we work out the value of I3 is 0.067. Now, if I substitute the value in the second one, if I substitute the value, like I got the value for I3, if I substitute the value of I3 in this equation, so it is 6 is equal to 30 into 0.067 plus 10I1. When I simplify this, 30 times 0.067, 30 times 0.067, that is 2, because it's obvious it will be 2. 2.01 or 2, because here we divided. So this will be 2 plus 10I1. This will move other side. So 6 minus 2, that is 4, is equals to 10I1. And 4 divided by 10 or 2 by 5. So 0.4 we will get. So I1 is equals to 0.4 ampere. So value of I1, we got 0.4 ampere. So we got I3, we got I1, and now we need I2. So if we need I2, we'll use the first equation. What is the first equation? According to the first equation, I1 plus I2 was equals to I3. So I1 is 0.4, I2 we don't know, and I3 is 0.067. When we move I2, so it will be 0.067 minus 0.4. What is the answer? We got minus 0.33. Okay. So we got minus 0.33. Negative. What is the significance here of a negative sign? It means actually what happened, if we are getting a negative answer, it means the direction of the current which is shown in the diagram, like I2. So in the figure, I2 is given in this way. But in practical, what will happen? I2 will flow in opposite way. Like the direction of I2, which is given in the question, is different from actual value. That's why we are getting a negative answer. That is the significance of the negative sign by using a Kirchhoff law. Is it clear? Any doubt in this? So if you get a negative, if you're getting a negative answer, it means the direction of the current is actually opposite to the direction which is given to us. Another example of the Kirchhoff's law. Say we have a circuit, a 5 volt, a fixed resistor, which is 10 ohm. The current I is flowing through this resistor. We have a 20 ohm and a supply of a 2 volts. Then we have another 5 volt supply. We have another 5 volt supply and a 10 ohm resistor. First, this question may look like circuit I drew may look complicated, but it is a very simple type of a question. Which loop I should select? Loop 1, loop 2, loop 3. To work out, the question is we want to find I. So which loop I should select? Loop 1, 2 or 3? The top, the middle or the bottom? So I should take the first loop because the top loop is having I. So I'll take the first loop. When I take the first loop, the total EMF must be equals to total potential difference. So if I take the first loop, the total EMF is 5 there. And should I add or subtract this 2? Should I subtract the 2 or add the 2? Because there are two supplies, 5 volts and 2 volts. Add or subtract? So I should subtract them. Why? Because look, plus this is trying to push the charges in this way. And the 2 volts is trying to push the charges in opposite way. So when the two supplies are like pushing the charges in opposite direction, we subtract them. So it will be 5 minus 2 in this case. And what about the total potential difference here? What about the total potential difference? So the total potential difference will be I into like 10I. I can also say 10I. Then this current I will divide into the component. Why 10I? Because the current here is I and the resistance is 10I. But the problem here that this current I is divided into two parts. So this will be I1 and this will be I2. And the current here will be I. So this will be equals to 10I plus 20I1. Is it clear? Is it clear? Okay. Look, why in the circuit, see, this was a circuit. I will draw the circuit. We were having a 5-volt supply and we were having a 10 ohm resistor, okay? And we have a 20 ohm. Then we have 5 ohm, 5-volt supply. And then we have 10 ohm resistor. So what happened? Say, because we need the current I in the question, so the current I will flow from here, okay? But when this current I is flowing from here, it will break down because it's branches. So example, this will turn into I1 and this will be I2, okay? And this I1 will flow from here, and this I2, when it enter another branch, the I2 will further divide into I3 and I4. And then this I4 will flow from here and I3 is flowing from here. So when I3 and I4 will join together, what they will make? They will make I2. And when I1 and I2 from here join together, what they will make? They will make I. Is it clear? The division of the current. So this is a 5-volt supply as well at the bottom, which I missed, but it's the same. It would not make difference to the current. So what we did, we formed this equation. This is one of the equation. Now, so before this, forming this equation, like applying the second law, we can also apply the first law, Kirchhoff first law, when multiple loops are there. So I can say according to this, I is equals to I1 plus I2. I can say like this, because as you can see here, the point. Then I can also say that I2 will be equals to I3 and I4. These are the two equations which we can form about the current. Now, when we take the top loop, the total EMF must be equals to total potential difference. What is the total EMF? The total EMF, because we have two supplies, 5 and 2, but in opposite direction. So it will be 5 minus 2. So this will be 5 minus 2. The total potential difference here The current is I and the resistance is 10, so I can say it will be 10I. Plus the current here is I1 and the resistance is 20, so it will be equals to 20I1. So this is the first equation, that 3 is equals to 10I plus 20I1. That is our first equation. Now when I take the loop in the middle, when I take the middle loop, the total EMF in the middle loop must be equals to total potential difference. What is the total EMF? Like two supplies are there in the middle loop. Like you ignore everything, you just consider the middle loop. Now what will be the direction of the flow? The direction of the flow will be like this because the 5 volt is higher. So direction of flow will be like this. So what is the total EMF here? The total EMF is 5 and 2. So should I add them or subtract them? So good, that will be 7. So it will be 5 plus 2, which is 7. And what about the total potential difference in this? In this loop, we have only one component, which is 20 I1, like 20 ohm resistor. Why we are taking a middle loop? Because in a top loop, when we took the top loop, we have two unknowns. So we cannot solve this equation. So that's why we took the middle loop. Why I added the voltage, as you can see here, the middle loop, if I just draw the middle loop, this is a middle loop. Here is a 5 volts and this one is a 2 volts. So the direction of the flow, what will the direction of the flow? Like 5 volt will push. So this will be the direction of the flow. So because they are both pushing the charges in the same direction, so as both pushing the charges in the same direction, so the total EMF will be the sum. That's why it will be 5 plus 2. If they are pushing the charges in opposite direction, then we'll subtract them. Is it clear? And the current here, we will take the loops until we get the two equations which are having, like, if for example, if we got I1 from this one, we will not take the third loop. So if we, according to the question, this is given I1, so what is the total? And this is 20 ohm resistor, so the total potential difference will be 20 I1. So the total potential difference will be equals to resistance 20 and the current is I1. So when we simplify, 7 is equals to 20 I1. 7 divided by 20, what's the answer? 7 over 20, what's the answer? 0.35. So means the value of the I1 is 0.35. Now the value of the I1 is 0.35. Now we can use this equation. We can use this equation because the problem, initially we were not having the value of I1 and I, but now we got the value of I1, so we can just substitute the values here. So 3 will be equals to 10I plus 20 times 0.35. So 20 times 0.35, what's the answer? 7. So this is 7, it will move other side. Yeah. So this is 3 is equals to 10I plus 7, and then 7 move other side, this will become minus 4. So minus 4 is equals to 10I, or minus 4 divided by 10 is equals to I. So means minus 0.4 ampere. So value of I is equals to 0.4 ampere, but negative. So what it indicate, if we get a negative value here, so what it indicate, the negative value, it indicate that the direction of I is opposite to the direction which is given in the question. Like we took in opposite direction. Is it clear, this example? The negative sign only indicate that the direction of the flow, the direction of the current which is taken is opposite. The direction of I1, I2, I3, some questions it might be given, some questions they don't give, then you have to take that direction. If you are taking a direction, in that case, for example, like when you take the direction, say we'll take the two loops again. Just I want to clarify one point that we have a battery is there and say two resistors. And this is a 6 volt supply and this is a 2 volt supply. Okay. And the resistors are given, it can be any number like let's say 30 and 10 ohm. And in this question, the question is find the current in each resistor and the direction of the current is not given. Okay. So if the direction of the current is not given and you have to take the direction, so what you will do, like example, you started with a maximum value, you call that as I1, maximum EMF value, you call that as I1. And then it will break down into the branches. This will be I2 and this will be I3. So this will be I2 and this same I2 and this is this is I3. And here I2 and I3 will combine. Again, it will make I1. In this question, what if the direction was not given to you and you have to take a direction? So you took this as a direction. Okay. That's first thing. Like how you will take a direction, you will select the maximum EMF supply, like the highest value of EMF supply, and then you will take the direction of the current in the same as in each loop. Like the current will flow from positive from a higher value. Some of the current will flow in the first loop, some of the current will flow in the second loop. Now, when you apply the Kirchhoff law, like when you apply the circuit law, like when you apply first law, so according to first law, the total current enter a point will be equals to leave the point. So in this case, I1 is entering and I2 and I3. So I1 will be equals to I2 and I3. That is one equation. When you apply the Kirchhoff's second law, then you have to take the loops. Example, we took the first loop and the direction of the flow in this way. So when we took the first loop and the direction of the flow, so according to the Kirchhoff's second law, the total EMF must be equal to total potential difference. So in that case, the total EMF here is a 6 volt, so we write 6. The total potential difference, because the direction in which we are taking the flow and the I2 is in the same direction, so we'll say this as a 30 I2. And here also the direction of the flow is same as the direction of the current I1 which we took. So we took as 10 I1. That is when we took the first loop or the top. Then we take a bottom loop. When we are taking a bottom loop, we consider that is the direction of the flow in this way. So when we consider the direction of the flow in this way, according to the supply, or I will, so we took the direction of a flow in this way, or if I change, because then it will be understandable. Like, so if I change the direction of this terminal, say So this is positive and this is negative. So we took a direction of a flow in this way. Now we are taking a direction of a flow in opposite way as the direction of the current we assume. So we apply the Kirchhoff's second law, the total EMF must be equals to total potential difference. So the total EMF here is what? It is 2. What about the total potential difference? So that is 30 resistance, but the direction in which we are taking a flow of the charges and the direction in which we drew I2 is an opposite. So when the direction of the flow we are taking and the direction of the current is opposite to our flow, we'll take as negative. So we'll say this is minus I2. Is it clear? If we were taking the same as the direction of the current, we'll take as positive. But if we are taking opposite, we'll take as negative. So we'll not say it is I2, we'll say it is minus I2. So this is important thing, like the sign convection is important, that the direction of the, if the direction is given to you and you're taking a direction from the supply, if it is, the current is in the same direction, take as positive. But if the current is in opposite direction, take as negative. Is it clear, this concept of the Kirchhoff's law? Another example applying the Kirchhoff's law. Let's say we have a circuit, a 20 ohm resistor connected to a 10-volt supply. And we have ammeter 1 here, or ammeter 2 and ammeter 1. And the direction of the current is not given to us. We have to take, so this is a 10-volt supply. Say this is a 5-volt supply. And we have A3, ammeter 3 and a 20 ohm resistor. First thing what you have to do, you have to take a direction of the current. Like always, best idea is take the highest value of the EMF and draw the current according to that one. So say this current is I1, okay? And this will also be I1. Then this I1 will break down into I2 and I3. And then this will flow. So this will be I3. So when I apply the first law, according to Kirchhoff first law, I can say that I1, the current enter a point will be equals to I2 plus I3. That's the first law. Then we take the loops. This will be our first loop. If we take a direction and we take a direction of flow from, this will be the second loop. So if we take, or even I can take this as one loop as well. Like I ignored this I2, I can take this as one loop. It won't make difference. So if I take the first loop, the total EMF must be equals to total potential difference. What is the total EMF here? That is 10. The total potential difference, because look, the direction of a flow and the direction of a current which we assume is same. So we write as 20 I1. That is, and there's no, this one is there in the same work. So direction of the flow and the direction of the current is same. So we took that as, we assume, remember one thing, because we ammeters, the reading of ammeter, the voltage across the ammeter is negligible. So even though it will have some voltage, but that is always our assumption that there is no voltage drop across ammeter. Like here is 0 volts, here is also 0 volt. That's our assumption. Practically there is some voltage, but we assume there is no voltage across the ammeter. So we write as 0. So we can say 10 is equals to 20 I1. So we can simplify this equation. 10 divided by 20 is I1, or it will be 0.5. So we got the value of I1, which is 0.5. Then we take the second loop. Why 0? Because Ammeters having a negligible resistance, a very low resistance. That's why ammeter potential across ammeter is negligible. So we consider it zero. Practically, it will have some, but assumption is it always zero as it has a very low resistance, so it does not consume any energy. That's assumption. If we take the second loop, so for the second loop, the total EMF must be equals to total potential difference. So we've already worked out I1, but why? Because we need I2. So that's why we're taking a second loop. Like we will find I3 from this, and then we can work out I2. Because if I know I1, but I cannot substitute I1 here because I2 and I3 are unknown. That's why we are taking a second loop. So in the second loop, the total EMF is 5 and the total potential difference, this ammeter will be 0 volts, this also 0 volts. So this will be 20 I3. And 5 divided by 20 is equals to I3. So 1 by 4 or 0.25. So we'll get 0.25 ampere. That is I3. Now we got I2 and we got I1 and we got I3. So we can work out I2. Is it clear, this example? So why we took a second loop? Because even though when I take the first loop, I will get the value for I1, but that will not be enough to get the remaining. So simply according to the Kirchhoff's second law, the total EMF in a circuit will always be equal to total potential difference.